Dimensional analysis notes. You're going to have to check the table of contents to see what page this should be in your journal. Excuse me. All right, so dimensional analysis, we're just going to start with like what this lesson entails. So we're going to be looking at the ratios of two or more similar shapes, side lengths, perimeter, area or surface area. I put the surface in square brackets because it could apply to just regular area and not surface area as well. And volume. Okay, so we're going to start just kind of by looking at the relationship between two similar figures. So we're going to start with the scale factor. So the scale factor will be the ratio of the side lengths. So I'll just put side lengths in parentheses. So the ratio of the side lengths would be like x to y, for example. I'm just using variables. And then for the perimeters, if you were to compare the ratio of the perimeters of that same shape, or the base perimeters, if you're talking about a three-dimensional shape, that would also be x to y. If we're going to talk about the surface areas, and again, this would apply to two-dimensional shapes as well, so I'll put surface in square brackets because it could just be area. That would be x squared to y squared. So whatever the scale factor is, you would just square both numbers, and that would give you the ratio of the areas. And for volume, just take the surface area and cube the x and the y, or cube the first and the second number in the ratio. Okay, so we're going to go ahead and start with the examples. There are going to be three examples. So if you want to section your page into three sections, like horizontal sections, I guess, you can do that. So example one, if the scale factor is 2 to 3, we want to find the ratios of, okay, so let's talk about the ratios of the perimeters. The ratios of the perimeters would be 2 to 3, because if you remember up here, it should be the exact same as the scale factor. The ratio of the areas, or the surface areas, again, I'm putting this in the box because the brackets, because it could just be regular old two-dimensional area. That would be 2 to the second power to 3 to the second power, so that would be 4 to 9. I'm gonna put a box around these so we understand what the actual answers are. And then for volume, that would be 2 to the third. Oh, sorry, that's confusing. 2 to the third power to 3 to the third power. So that would be what, 8 to 27. Okay, so that's example one. That's how you do those types of problems. Now let's look at example two. All right, so for this example, we're going to be looking from left to right. Find the surface area. I don't know. Should a comma go there? I don't know. Find the surface area. Oh, sorry, the scale factor. Find the scale factor and the ratios of the perimeter the surface area and the volume. Okie doke. Okay, there it is. Okay, sorry, I was struggling. All right, now that I've got my life together, we're going to draw two similar cylinders as best you can. Doesn't have to be drawn to scale or anything. Just make sure that one is bigger than the other. Okay, and this is going to have a volume of 19,440 pi yards. Since it's volume, it's cubic yards. And okay, we're going to draw a smaller cylinder. My drawings are amazing. Thank you. And this volume is going to be, what is it, 11,250 pi yards, cubic yards. All right, so we really don't need any other information. We're good with that. So the first thing we want to do is, since we have the volumes, we're going to reduce and find the scale factor from there. So we're going from left to right. So we're going to start with the volume on the left, and then we're going to put it over the volume on the right, and then we're going to simplify. And since there's pi in both the numerator and denominator, that can cancel out. Since both the numerator and denominator end in 0, we can ignore that. And then you can just put 1,944 and 1,125 in the calculator, divide them out. You should get 216 to 125. And so that is the ratio of the volumes. That was the ratio of the volumes. So since that is the ratio of the volumes, I told you the relationship between this and this is to the third power. But since we are starting with the volume ratio, we're going to have to do the opposite of third power, which would be the square root. I'm sorry, the cube root. Cube root. So the cube root of 216 over the cube root of 125. It is not equal to this. Those ratios are different, excuse me. Okay. All right, and then once you do that, you should get 6 to 5. So that is the scale factor. So the scale factor is 6 to 5. That's one of our answers. The ratio of the perimeters, or the base perimeters, would be also 6 to 5, or the circumference, the ratio of the circumference, since they're cylinders. And then the ratio of the, what do you call it? Give me a second. Surface area, sorry. The surface area ratios, I'm gonna put an arrow because it's technically not equal per se. And so that would be 6 squared, which is 36, to 5 squared, which is 25. And then the volume ratios would be 6 to the third power, which we already know was 216, and then 5 to the third power, which we already know was 125. That's the one we had started with anyway. Okay, so that's the end of example 2. We got a little bit of space left for example 3, which is perfect because that's what we needed. All right, so this time we'll write a lot of instructions. Given the scale factor, the scale factors, surface area, and volume of the smaller shape, or I'll put figure. Find the surface area and volume of the larger figure. Yuck, that you was struggling. So given, this information that I'm writing over here is given. So the scale factor is 1 to 2. The surface area of the smaller shape is 99 square meters. The volume of the smaller shape, excuse me, is 378 cubic meters. So now we need to find the surface area and volume of the larger shape. So we don't want the ratio. We don't need the ratios. We want the actual surface area and volume. So for surface area, don't forget that we're going to take the scale factor and square both of the numbers in the ratio. So that'll give us, 1 to the second power. Lord, I can't talk. 1 to the second power is 1. 2 to the second power is 4. So I'm going to use that ratio in fraction form, and we're going to set up a proportion. So since 1 is smaller than 4, and we know that this is the surface area of the smaller shape, we're going to put it at the top with the smaller number. And we're looking for the larger number. And when we cross multiply here, we should get 396. And if we cross multiply the 1 and the x, that's just 1x. Or I'm just going to write x because why waste my time? So that would be 396 square meters. We're going to repeat those steps kind of sort of for volume, only this time we're going to cube both of the numbers of the ratio. So that's going to be, let's see, 1 to the third power is just 1, 2 to the third power is 8. And then the smaller volume was 378. We're going to put that over x and solve for x. When we cross multiply, we get 3024. And when we cross multiply this way, we get just x. And this is cubic meters, and that is that.